Hey everybody, in today's video, I'm going to show you how to generalize two-way recursion in Python for a function like a Fibonacci sequence that can be implemented as a recursive relationship of the same function applied to two smaller values. The Fibonacci function really just involves starting off with the numbers 0 and 1 and iteratively adding them together. So you combine 0 and 1, get 1, 1 and 1 get 2, 1 and 2 get 3, 2 and 3 get 5, 3 and 5 get 8, 5 and 8 get 13, and so on. And the function is generally better implemented as an iterative function, but it's certainly more expressive to implement as a recursive function because the essential Fibonacci relationship, if you temporarily ignore these first four lines of the recursive function, the definition of a Fibonacci number for any number I greater than or equal to 2 is just that it's the sum of the prior two Fibonacci numbers. And that implementation is very expressive, but it's also very slow. And it's a little bit out of the scope of this video for me to explain why that is. But essentially what you end up doing is you end up recomputing the same numbers over and over again. And you actually get like an exponential number of calculations for a particular value of I. But again, that's a little bit out of the scope of this video. But I'm going to run the program that we have right now. I'm sorry, I think I have caps lock on. Oh, there I go. And what I'm demonstrating in this output right down here is that when I run the program in an iterative fashion and I just simply, say fib 0 is 0, fib 1 is 1, go in this loop and compute it in iterative function, that I get the exact same values as when I call this recursive fib function up top, which every time through the loop is doing a recursive calculation that sort of filters down through all the through the search tree. But if we run it again just to demonstrate it is working. So I want to solve the problem that even though this is a very expressive way of writing this function, it's inefficient. So what I want to do is I want to generalize the notion of recursion, the notion of two-way recursion. So what I'm going to do is I'm going to eliminate my naive version up here. Now when I run the program, I expect to get an error that says that recurse fib is undefined because I just eliminated that function. And of course I get that, but now I'm going to replace, recurse fib with this recurse fib 2. I don't need that print statement. That was from a little bit of debugging. Now if I run that, I get the exact same output. So now I have a new version of recurse fib that is more generalized. So what I'm saying here is that I have my base cases where I'm going to map the input value of 0 to the output value of 0, the input value of 1 to the output value of 1. I'm going to have a notion of splitting up the problem. And I call this split combine. You could also think of this as divide conquer. So if I need to, if I'm not able to satisfy the function by applying one of these base case values, then I need to split the function or split the problem in terms of computing over either the value or both the values n-1 and the values n-1, 2. And then when I come back and combine things, I just need to add the two numbers. And that goes back to the earlier definition of the Fibonacci sequence, where every Fibonacci number is combining the two previous values with the very simple notion of integer addition. So I set up essentially the three things that are important for the recursion. I have the base cases, I have the way to split the problem, or you can call it dividing the problem, and a way to combine the results, which you could think of as the conquer step. And then I call general recurse on that. My general recursion is that I say, if my number is in the base cases, then I just look up, the base cases dictionary that was passed into me, and I return the result. Otherwise, I split it into two different smaller values that I need to compute over, and then I return the combination of them. So in this video, all I'm showing you is the generalization that I'm making to generalize the problem, but I'm not doing anything in general recurse to make it more efficient. So in a subsequent video, what I'm going to show you is how I can use general recurse in a general way to make computations over these like two-way recursive functions more efficient. And the basic idea is that if you can say that the value of a function evaluated over n is somehow combining the values of the function evaluated at two smaller numbers, in this case n-1 and n-2. If you can express a function in that way, then what you should be able to do is have some way of not computing the same smaller values over and over again. And that'll be for a future video. There are like very simple techniques of memoization. I might try to over-engineer it a little bit just to show you guys some stuff. But that's the basic idea. And I'm going to run it now just to show you that this works. Obviously, I tested this before. And sure enough, when you call this recurse fib with the general recurse method, the general recurse method does the right thing. And of course, the recurse fib is more convoluted in some way, but it does kind of express the basic recursive relationship. You have this idea that you have base cases, you have this notion that you're able to split the problem up so that you're computing things over smaller values, and then once you compute the function over those smaller values, then you combine them together. So I hope to have a follow-up on this soon. Please put something in the comments if you would like to influence what I do in the next step. And I hope you guys learned something from this, and I hope you enjoy it. Thank you very much.